Hello and welcome. Today I'll be doing a video assignment for MA210. My name is Jack Banzurkh and we'll be working on a jar related problem. Alright, so we'll be working on a jar opening problem because when I was opening a jar and I let go, it had an initial rotational velocity before it stopped, like a few centimeters above where it started, and this made me like somewhat focus on the conservation of energy, but not so much in this case because I want to focus on the work that's done in a system to reduce the total, well, energy in the final result, because uh, I'm pretty sure the friction force between the lid and the jar reduced the speed by a lot, which heavily affected the potential energy in the end result. Alright, to start off, I gave myself a question, which was how much work is done on the system after the lid has been released until it stops, which is basically when I let go right after the lid loosens and it like spins around for a little bit or like rotates. And there's some data here in my givens and assumes that are somewhat meaningless, but that's all right. So to start off with, we obviously got the diameter, and for the initial angular velocity, I calculated it to be 7 radians per second, and the mass of the whole thing is going to be 0.25 kilograms. The time it took for the whole thing to spin and stop was only half a second, which is rather quick, and obviously the final velocity, angular velocity, is going to be 0. The height of this lid is 0.25 centimeters. It's small, but that's fine. And it only rises by a very meager 0.1 centimeters. And so I used conservation of energy, which is right here, but it's not conserved because there's work being done to it. And I just want to break down the equations. So I moved this to the other side, moved this right here, broke it down to its components. And the first thing right here is that there's inertia. Because this is a cylinder and it's got some complex edges, but I don't really want to do that. So I just concluded to like a cylinder that's filled solid, which gives me this equation, and I just plug in the givens, such as the mass and the radians, and I get this as my final inertia. And with this, I basically can just plug in everything else and get the work right away, which is obviously 0.5 and the initial rotational velocity and the inertia I got from that minus the mass, gravity, change in height. This whole thing eventually gives me 0.002448 joules. And that concludes the problem. This was rather straightforward, but I think it gave me a good idea on like the conservation of energy, which I also hope helped you as well.